Okay, this video we will be discussing the properties of logarithms. We have three properties that we are going to discuss initially. We have the product rule, in which we're taking the log of m times n, and you can split that up or expand that into the log of m plus the log of n. Then we have the quotient rule, in which we're taking the log of m over n, or m divided by n, and that will expand to log of m minus log of n. And then the power rule, if I have the log of m raised to the p power, I can bring that p to the front, and that would be p times log of m. So if our directions were to simplify or to expand, if I have log of 10x, since I don't see anything for the base, that lets me know I have my common log, which is log base 10. So I would break this up, if I wanted to simplify as much as possible, to the log of 10 times x, not 2 times 5 times x, but 10 times x, so that I can have the log of 10 plus the log of x. And whenever I have multiplication, that's the product rule, I can expand it or break it up into two different logs, log 10 plus log x. Then the log of 10, log base 10 of 10 is just 1 plus, and then the log of x. Second one, I have log base 5 of 75. Here, I would break it up into 3 times 25 because I have log base 5 here. And I can take that 25 and rewrite it as a power of 5. So it'd be 5 squared, or a multiple of 5. So that's log base 5 of 3 plus log base 5 of 5 squared. Log base 5 of 5 will cancel, leaving you with just 2. So it's log base 5 of 3 plus 2. Here, we have the log base 7 of 19 over x. 19 is a prime number, x is just x, so there's nothing we can do to break either one of those down. So if I just wanted to expand it out, and I made a little mistake right here, but this is log base 7 of 19 minus log base 7 of x. Okay, next one, natural log of e to the third over 7. So break it up into the natural log of e to the third power minus natural log of 7. Natural log is the log base e, so natural log of e will cancel, leaving with just 3 minus natural log of 7. Next one, if I wanted to use the power rule, I have log base 5 of 7 to the 4th power. I can bring the 4 to the front. That's 4 times log base 5 of 7. And then here, natural log of the square root of x. The square root of x is x to the 1/2 power, just like the cube root of x is x to the 1/3 power. Fourth root of x is x to the 1/4 power, and so on. So I recognize that, and then that means I can bring the 1/2 down front, and that'll be 1/2 natural log of x. All right. So let's take those rules and continue to expand. This next example, log of x squared times square root of y. I recognize that that's square root of y is y to the 1/2. Also, since they're being multiplied, I can break that up into log x squared plus log y to the 1/2. Then I can bring the square down front and the 1/2 down front, giving me 2 log of x plus 1/2 log of y. Next one, log base 6 of the cube root of x over 36y to the 4th. So I recognize that the cube root of x is x to the 1/3. So I rewrite that, and then the quotient rule say I'll have x, or log base 6 of x to the 1/3 minus log base 6 of 36y to the 4th. Now that log base 6 of 36y to the 4th, that's multiplication, so I can break that up. Notice my parentheses here. Both of those are in our denominator, so that means that minus sign needs to be applied to both of them. So that's log base 6 of 36 plus log base 6 of y to the 4th with parentheses around them. Negative sign sitting on the front. Now I can distribute that negative to each term. So notice each term that came out of my denominator will be minus or will be negative. So that's log base 6 of x to the 1/3 minus log base 6 of 6 squared. I turn that 36 into 6 squared since I have a base of 6. And then log base 6 of y to the 4th minus log base 6 of y to the 4th. Then I can finish it off by bringing the 1/3 down front. I can simplify the log base 6 of 6, and that cancels, leaving me with just 2. Bring the 4 down front. So I have 1/3 log base 6 of x minus 2 minus 4 log base 6 of y. All right, let's look at the next one. I want to write as a single log. This time we want to, wherein before, notice the directions. They ask us to expand. In this exercise, they're asking us to write as a single log or to subtract. So we want to bring our logs together using the same product, quotient, and power rules. So I have log base 4 of 2 plus log base 4 of 32. Since that's the addition, that means if I want to write it as a single log, I will be multiplying the 2 and the 32. 2 times 32 is 64. Log base 4 of 64, you always examine the terms being applied by the log to make sure that it cannot be rewritten in terms of the base. And 64 is 4 cubed. So I can write that as log base 4 of 4 cubed. Log base 4 of 4 will cancel, leaving me with just 3. Next one, log base 4, log of 4x minus 3 minus log x. And so there's nothing that can be reduced or simplified according to the base. So I would just rewrite that, condense it down to one log, and that'll be log of 4x minus 3 over x. All right. Next one, I have 1/2 log of x plus 4 log of x minus 1. First thing I'll do is bring take my 1/2 back up to the power, take my 4 back up to the power. So this log of x squared plus log of x minus 1 to the 4th. And since I have addition, I will use the product rule. So that'll be log of x to the 1/2 times x minus 1 to the 4th. All right, next one, 4 log base b of x minus 2 log base b of 5 minus 1/2 log base b of y. Take all the numbers sitting in front of the log back to the powers. So that'll be log base b of x to the 4th minus log base b of 5 squared minus log base b of y to the 1/2. Remember, if there's a minus sign in front of your log, that means it should go in your denominator. So I will bring the negative out front. That's log base b of 5 squared is 25 plus log base b of y to the 1/2. Those terms will come together, giving you a log base b of 25 y to the 1/2. So you use the power rule, use the product rule right there to bring those together to make a single log that's in your denominator. Now we have log base b of x to the 4th minus log base b of 25 y to the 1/2. Now that I have just that, I can bring those together using the quotient rule, and that'll be log base b of x to the 4th over 25 y to the 1/2. Last property in the section, log base b of m is going to be equal to log of m over log of b if you decide to use the common log, or natural log of m over natural log of b. It's called the change of base property or the change of base theorem. In your calculators, a lot of scientific calculators only have the option of using the common log or the natural log. So if you have a base that's something other than 10 or something other than the base e, we use the change of base property, use the common log or the natural log to be able to figure out what the numerical representation of that value is. So let's take one example and use the common log and then the natural log and see if we get the same answer. So we have log base 5 of 140. Your base will always go down bottom. So if I decide to use the common log, that's going to be log of 140 over log of 5. The base goes down bottom. The other number is the one that goes to the top. And then if I decide to do the natural log, once again, the base goes down the bottom. So I have natural log of 140 over natural log of 5. Notice when I apply both of them individually, I get something different in the numerator and denominator. In both cases, I get 2.146 on top. In the first one, using the common log, and 0.6989 on bottom. Using the natural log, I get 4.9416 on top, 1.6094 on bottom. So once I divide them out, I will get 3.07 as my answer. So the log base 5 of 140 is 3.07. And it doesn't matter whether you use the common log or the natural log, you still get the same value. Let me know if you have any questions.